Hi, everyone. Welcome to the Doc AI session. I'm Sudheera Vanguri, and I'm the product manager for Document AI and Natural Language in Google Cloud. Today, a quick run-through of the agenda. I'll be covering some of the challenges and market opportunities related to documents and AI. I'll then dive into a product overview and try to unbundle some of the technologies that we use under the hood. We will have time for some Q&A towards the end. So let's dive right in. Customer expectations are higher than ever, and businesses are always constantly looking for ways to innovate, stay ahead of the market and competition, and stay relevant. For example, energy companies are looking for ways to understand scores of documents archives from over 100 years old to understand the risks associated with new sites, assess opportunities by unlocking various insights stored within these documents. Mortgage providers are trying to cut processing times, which have now reached over 45 days. Insurance companies are looking for ways to cut underwriting times. Can you figure what's common in all of these processes? Most of these processes begin or end with a document. We have RPA vendors citing that over 50% of their workflows begin with a document. Most businesses are now sitting on document gold mines. These documents are contracts, PDFs, emails, customer feedback, patents, and these documents are only going to grow with time. Now, it's not just the volume that we're talking about. The complexity of these documents has also increased vastly over time. And to add to the complexity, there's a lot of external data sources, external knowledge sources that are referenced within these documents. The semantic depth of these documents, linking entities across each of these documents, present new opportunities for businesses to understand various document sources spread across various business units within the organization. Now, 20% of the enterprise data is structured. What do you mean by structured? This data is typically, think of a spreadsheet or data that's easily entered into a database. Now, this data is highly organized, formatted, and there are various mature data analytics tools out there that enable you to mine this data and derive insights and make business decisions from these enterprise data. Now, 80% of enterprise data is still unstructured. Some examples of this unstructured data includes emails. Now, these are all human-generated customer reviews, PDFs, audio and video files. And some of these are machine-generated, like satellite imagery. The tools to mine this type of unstructured data is still very nascent. And a lot of machine learning expertise is required to understand and mine this unstructured data. The inability to understand this unstructured data leaves a lot of value on the table. Now, think about customer reviews, which are unstructured. This can lead to a poor customer experience if businesses don't pay attention to that type of reviews or email feedback that are sent to the business. This can also lead to operational inefficiencies, lack of insights within various unstructured data sources, and also exposes businesses to some compliance risks associated with analyzing huge volumes of documents. Document AI, in a nutshell, enables you to convert unstructured documents into structured data. Now, that means that you can marry unstructured data with structured data, and you can understand and utilize both these sources to make efficient business decisions and also cut processing times. Document AI enables you to read understand, that is, extract, and classify information from unstructured documents. This can unlock significant value in increasing operational efficiency, customer experience, as well as extract insights that you couldn't tap into before Document AI. Some of our customers are already starting to unlock value by, let's say, for example, you have a customer ID that can be linked across various business documents. You can stay on top of your PII and avoid compliance risks and process invoices more quickly. Think about the value and the efficiencies that you can generate if you had a tool that can enable you to unlock this value. Let's take some real-world examples and some real customer use cases that we have seen so far. A large US-based mortgage lending company has been able to use Document AI to analyze the 350-page mortgage application, classify it into over 100 document types, and then convert that document into structured data. Now you can analyze a mortgage application and convert that into structured JSON, such as here's the applicant name, here's the property sales price, or here's the down payment. Another customer, who again within the financial services segment, has solved a similar problem and have seen amazing results. With over 97.8% accuracy, they were able to analyze 700 documents in 2 minutes, scaling to millions of mortgage-related documents again. Let's look at the insurance segment. We have another customer that has been able to reduce their claims processing time by over 74%, with an accuracy of about 81%, using powerful combination of RPA tools, using Automation Anywhere, one of our partners, as well as Google's Document AI. A final customer example is our partner, our e-transaction partner, DocuSign. Please take a look at the demo. Here's an example of a document, an NDA, that a customer wanted to send, a DocuSign customer wanted to send to another recipient. Now, Tamara needs to sign this document. What's happening here is that Document AI has automatically recognized all the blank fields within that form, and those yellow boxes are dropped right on the places where there needs to be a signature or a date field or a name, so on and so forth. That's it. How was this possible? DocuSign used one of our products called AutoML entity extraction, as well as object detection, in order to analyze various documents, various contract forms, and identified a few fields, such as a signature field, a date field, so on and so forth, and train machine learning models to detect bounding boxes for various tags that need to be placed on these documents. Without Document AI, these yellow boxes were dragged and dropped manually by humans. But with Document AI, we're automatically able to detect various fields of interest customized to a DocuSign user's preferences. Let me unbundle and talk about some of the technologies that we're using under the hood. Now, picture yourself in a room full of documents. They're all over the place. They're on the kitchen table. They're all over there. And you would like to start analyzing these documents, figure out what these documents are. Are they contracts? Are they printed emails? How would you go about it? You'd probably start to read those documents. You'd probably then try to organize those documents and then try to maybe take a cursory glance at those documents, extract a few words here and there, and then try to understand how many document types you have, and then extract various things from those documents. Now, Document AI approaches these documents just as a human would. And what we mean by that is we use a combination of powerful computer vision, natural language, and knowledge graph techniques in order to read and understand these documents. Now, what do we mean by read? Google's OCR technology is unparalleled in terms of its state-of-the-art accuracy, as well as over 200 languages that we support. Our handwriting OCR supports over 50 languages, and we support various document formats such as PDF, TIFF. A new capability that we have recently announced that is coming soon is our form OCR capability that analyzes the structural elements of various forms and spits out key value pairs and the various elements of a table once you run it through our form OCR API. Here's an example of how New York Times has used our OCR technologies.
Is what makes the Times the Times. There's 600 cabinets, a few thousand drawers, 6 to 8 million photographs dating from the late 1800s on till the 1990s. This is the Flying Hunters. This ran in 1930. George Washington Bridge, France's biggest naval ship, American soldier greeting his mom, Christmas at Penn Station. I mean, there's pretty much anything and everything. The history of the world through the eyes of the New York Times.
I didn't think too much about it at first. Like, yeah, sure, we have photo archives, and then I learned more about it, and there were like millions and millions of photos down there that, except for like one person, nobody really knows what's hiding down there.
For every picture that we were able to publish, many never saw the light of day.
The more that I've worked down in the morgue, the more the real value and the real importance of having access to it dawned on me.
The exciting thing about this project is the New York Times has over 100 years of photos locked in a basement, and this project will allow people to see photos that have never been seen before and make them accessible to the newsroom at the New York Times.
When I first heard that there was a possibility of us digitizing this, I was really excited.
So Google and the New York Times have had a partnership for many years, and we think it's actually an ideal partnership to be able to leverage the power of Google Cloud's technology. What Google is bringing to the table is a lot of the infrastructure that the New York Times needs, as well as providing these sort of platform-level services on the Vision APIs.
The first part of the digitization process is obviously the physical scan of the photos, getting them out of folders, getting them out of all these boxes, and physically scanning them.
So here's the front of the picture, but the back of the picture is just as interesting.
The stamps, handwritten notes, etc., that tells us something about the photo, who took it, etc. That is the data we need to extract.
These markers all over the back are the clues for where the picture was used. So here it was published in the newspaper at least twice. Here we can see the captions that were taped on the back indicating publication. And along this top edge, there's a number. That is the indicator of where this photograph lives inside the morgue.
We'll upload them into tools which will allow the photo editors to search the archive and bring up the images they need.
So once we're done with this, it'll enable the newsroom to immediately access our entire archive from their desktop.
Once the pictures are digitized, I mean, everything old is new again.
We get the sense that covering current events is talking about what just happened, but having this resource available to reporters and editors gives them the ability to draw in all of the context of what preceded, the wider world that led to this contemporary event.
There is nothing else, no other way of reporting what goes on in the universe that can do that the way a still photograph can.
The idea of telling stories in pictures is how society works now.
For Google, our job is to make the world's information universally accessible and useful. And in this project, we're helping the New York Times with their data to be able to do that.
All right, that was New York Times. Let's now move into our natural language technologies. Now, our Cloud Natural Language API, which is currently in GA, has various features such as content classification, sentiment analysis, syntax analysis, and entity analysis. Now, what do we mean by each of these features? Content classification enables businesses to classify their content into over 700 categories. So think media, news and entertainment, politics. So these are commonly found categories on web articles, news articles, entities that you'd find on the web. Our entity analysis API, similarly, can identify over 10 different entity types. This include dates, addresses, phone numbers, again, entities that are commonly associated with web-based content. The syntax analysis API enables you to identify the prevailing emotion of a writer within a text passage. So positive, negative, or a neutral sentiment. And our syntax analysis API enables you to break a sentence down into its tokens or parts of speech, which can then be piped to do various interesting things such as build knowledge graphs or build recommendation engines. For example, our entity extraction API includes various fields that can help you analyze invoices. The entity types that we can understand include dates, addresses, phone numbers, companies, and what's more, that the address is pre-verified by Google Maps for you. Another example is the AutoML Natural Language product, a custom model building capability that we recently announced. How many of you have built a custom machine learning model or trained a custom machine learning model? How many of you have deployed that machine learning model for a production use case? Quite a few. Well, I hope that by the end of this session, you're as excited as I am to use AutoML, which can enable citizen data scientists with limited to no machine learning expertise to build a model with almost no coding involved. Now, how does that work? All you need to do when it comes to AutoML is provide a set of training data, and the training data can be associated with a classification model, a sentiment model, or an entity extraction model. We require at least 10 mentions for each entity type or 10 examples for a decent model and 100 for a good model. So in a few simple steps, you can upload some training data, click on train. It typically takes about 3 hours on an average for us to train a machine learning model. And then you can evaluate and look at some of the precision and recall metrics where we provide you some confusion matrices to understand where the model needs more examples. And the more examples you provide, the better the model gets. Behind the scenes, we run various machine learning models in order to get you the highest accuracy possible. With AutoML Natural Language, in addition to custom classification, entity extraction, and sentiment analysis features, we're also HIPAA compliant, which should be great news for our healthcare customers. Some new features that we've added recently include support for both text as well as document inputs. Now, analyzing a stream of text will become relevant for voice of customer analytics companies and media companies that are trying to analyze tweets, customer feedback, emails. And scan document input, especially PDF support, will become important for companies that are trying to do, as I explained before, some of the more advanced use cases, such as contract analysis, patent analysis, mortgage document analysis. Here's a quick demo. I'll try to provide a voiceover for this example. Businesses have various scores of document types. And these documents, as I mentioned, can be patents and various structured document types. Here's an example of a resume. Now, a resume can include dates, addresses, names, and various spatial features associated with that document. Font sizes may be relevant, headlines, titles may have more importance than some of the other features within the document. So a combination of natural language as well as spatial techniques may be needed to analyze these documents. Now let's try to see how we can extract and convert this document into structured data. If I could direct your attention to the screen, you have AutoML classification, sentiment analysis, and entity extraction. I'm going to click on entity extraction. This is how the interface looks. I have pre-created a resume data set and stored it on a GCS bucket. These are a set of PDF resumes. These are the examples that I was referring to. So I have a test, train, and a validation data set. AutoML does auto-splitting for you as well if test and train data sets are not provided. So within the import step of AutoML, we provide a link to a GCS bucket with these resume PDFs. Let's check if the resume looks all right. We provide a plain text view. We run OCR behind the scenes for you, so you can either upload pre-trained or pre-annotated documents, or we have an annotation UI that can enable you to select items such as skill or names or university, so on and so forth, and annotate these documents. As you can see, I have about 10 entities annotated on the resume. If everything looks good, all I need to do is click on train and start training. Go grab a cup of coffee and come back. It's going to take maybe an hour or two, depending on the size of your data set. And that's it. Without any machine learning expertise, we mimic a data scientist behind the scenes, do hyperparameter tuning, run multiple Google models, and then surface the best model, which has the highest precision and recall. You can also adjust the confidence threshold, and what you saw was the confidence matrix, confusion matrix. We then go on to prediction and test and use. So here I've uploaded a brand new resume, and as you can see, the model is able to predict with over 99% accuracy that Dale Snail refers to a name, various skills have been tagged, various items within that PDF document have been auto-tagged for you. So you now have a structured data output of various fields that you can then customize for your own domain. Now this can be applied to not just a resume, but any business or domain-specific use case. That's AutoML entity extraction for you. I have one more example of AutoML sentiment analysis. Here's, again, another quick demo.
Hey, today we're going to talk about how to build a custom sentiment analysis model with Google Cloud AutoML Natural Language. If you've played with the Natural Language API before, you might have seen that it can tell you the sentiment of a block of text, like whether a tweet is mostly positive or mostly negative. But what about for text with domain-specific language? For example, let's say we're trying to classify the sentiment of a tweet like, Delta, I was waiting on the tarmac for 2 hours. That's a made-up tweet, by the way. Sorry, Delta. An out-of-the-box sentiment model would tell us this tweet is neutral. It doesn't realize that being stuck on the runway is a bad thing. For this, we'll use AutoML Natural Language to train a custom sentiment model. To do that, we'll need a labeled data set. Today, we'll build a model that identifies the sentiment of tweets about airlines using a data set built by Crowdflower. To prepare our data set, all we have to do is save the tweet with their labels in a CSV. The leftmost column indicates what we should use a given example for, like testing, training, or validation. The label on the right are the tweet sentiment scores, which in our data set have been labeled by a human being. 0 is very negative, 1 is intermediate, and 2 is very positive. Within the AutoML Natural Language tool, we'll choose to launch an AutoML sentiment app. Next, we'll import our data by clicking Add Dataset. Here we want to choose sentiment analysis. We can upload the data by importing it as a CSV directly or as a zip file, but I've already uploaded my CSV to a Google Cloud storage bucket, so I'm just going to import it that way. Down here by sentiment scale, we'll tell AutoML the range of sentiment scores to expect in the dataset. Since our scores go from 0, the most negative, to 2, the most positive, we'll select 2 as the maximum sentiment score. Now the data is importing. This could take a few minutes to finish. Once data is imported, we'll see it here in the Text Items tab. We can click into an example and make sure it has the right sentiment score, or change it if it doesn't. Notice we also have the counts of how many examples we have for each label on the left. We'll need at least 100 examples per label to start training. We can begin training a model by navigating over to the Train tab and clicking Start Training. Training a model can take up to 3 hours, so hold tight. You'll get an email when it's done. When training's finished, we'll be able to see our model here in the Train tab. We can see how well it did by clicking See Full Evaluation. Here in the Evaluate panel, we can click in to see the performance of our model. The metrics we care about are precision and recall. Up top, we can see both, but if we click into a single sentiment label, we can see it broken down for each category. Precision tells us, of the tweets that our model did label 0, how many really were 0. Recall, on the other hand, tells us of all the entire tweets in the data set, what percent of those that should have been labeled 0 did our model actually end up labeling 0. Another useful tool is the confusion matrix. It tells us how the real labels of the dataset compare to the labels that our model predicted. For example, 91.3% of the time, the model accurately predicted that tweets with the label 0 should have had label 0. But 26.7% of the time, it also thought that tweets with label 1, those that are just neutral, should be labeled 0. If we click on one of these boxes, we see examples of what the model correctly and incorrectly labeled. In the Predict tab, we can start actually using our model hosted by Google. We just have to think of some positive and negative airline tweets to type into this box. And there we go. AutoML Natural Language's custom sentiment analysis feature knows that losing your luggage is not fun. That's all for now. Have fun modeling.
Our customers have used a combination of OCR, natural language, AutoML capabilities to solve various use cases across multiple verticals. I, for one, am constantly amazed by some of the more surprising ways that our customers end up using our products. We've seen use cases from media, news, and entertainment in analyzing sentiment of news articles. We've seen energy companies use Document AI to understand various patterns in geophysical documents. We've seen security companies use Document AI to classify various documents into sensitive and non-sensitive categories that can enable them to detect anomalous activities. The use cases are many and spread across various verticals that it definitely makes my job very rewarding. Tying it all together, now let's say you have a patent document and you've identified a strong use case to convert that into unstructured data. Here's how you would go about it. Use the OCR APIs. Sometimes the OCR API, if you're building an AutoML classification and entity extraction model, is embedded within the product. So using a single API call, you can both OCR as well as do language analysis on the document. So OCR enables you, optical character recognition enables you to read or convert that document into a machine-readable text. You can then classify that document to say that, well, this patent refers to a computer vision patent with over 96% accuracy. You can then extract entities from within that patent document. So here, for instance, I've been able to extract the publication date, application number, filing date, so on and so forth from the patent document. You can also detect diagrams from within that patent document using AutoML object detection. And then finally, store a structured version of that unstructured patent document in BigQuery. That's it. So if you have a strong use case for Document AI, I would encourage you to identify and prioritize some of the workflows that will benefit the most from converting that unstructured document into structured data. So think about the efficiencies, the cost savings that you could get by cutting the doc processing times associated with that workflow. Now, if you'd like to go about this journey with a partner, here's a website that we've listed some of our partners that have expertise and experience in using Document AI technologies. Or if you'd like to go about it in-house, please visit our website, cloud.google.com/solutions Document AI. thank you very much for your time today. I hope the session was useful. I'd love for you to ask any questions that are related to Document AI. I'd love to understand more of your use cases. We'll save some time for Q&A now. Thank you.